Hello students, welcome back to this new session on mathematics. Here I am continuing the same topic of inverse Laplace transform, but in this session I'll be working for the inverse Laplace transform of logarithmic and inverse functions. Okay, now this thing works on one of the properties which you'll have learned already in my previous sessions. Okay, I hope you all remember all the properties which I have taught you in the previous sessions. So just like I have just written it on as a note on your screen, you can see, we know that the Laplace transform of t raised to n into f of t is equals to -1 to the power n nth derivative of f bar of s. Okay, where your f bar of s is the Laplace transform of this f of t. Okay, so this property you have learned already in my previous session. You have also solved, we had discussed the problems through the sessions on this property as well. So now I'm just using it to work on inverse Laplace transforms as well. So how are we going to work for that? Now just pay attention all of you. When n is equal to 1 in particular or 2, the same property I can write it as the Laplace transform of t into f of t, I can write it as minus d by ds of f bar of s. Is it? Similarly, if I take the reverse of it turns to be t into f of t to be L inverse of minus d by ds of f bar of s for n is equal to 1. Yes or no? For n is equal to 1, the same property takes the value -1 to the power 1 first derivative of f bar of s, is it not? Similarly, for n is equal to 2, the property can be written as t square into f of t -1 to the power 1, -1 to the power 2 is 1, second derivative of f bar of s, you write. And if I take inverse Laplace, so inverse Laplace of transform of second derivative of f bar of s turns out to be t square into f of t. Yes or no? So and so on, you can just continue with it. Now based on this we'll be working certain problems. So all of you take a pen and a paper and start working for the problems with me. Okay, this is the important part that you need to know. Okay, so see here. The two important things which I'll be using to work with the problems, I've just written it on the top, that is L inverse of minus d by ds of f bar of s is equal to t into f of t, and L inverse of second derivative of f bar of s is equal to t square f of t. These two things I'll be using. So I have just written it on your screen. Now let us work for the problems. Example 1, say cot inverse of s by a. Okay, now have you ever got your Laplace transform to be cot inverse of something in your previous in your derivations for the standard functions or something? Nowhere you have got, is it not? So to solve such a problem, that is, it has appeared in inverse this. So the solution goes as, so what you're going to do, you're going to first take this as f bar of s. So let f bar of s is equal to cot inverse of s by a. Okay, now you should try to eliminate this cot inverse from here. So for that, what we will do, we'll differentiate this with respect to s on both the sides. So simply differentiating this with respect to s. Okay, so differentiating the left hand side, you will get d by ds of f bar of s is equal to derivative of cot, it is -1 divided by cot inverse x derivative is -1 divided by 1 divided by 1 plus x square. Okay, cot inverse x derivative, but in place of x you have got here s divided by a, so it will have 1 plus s square by a square into the derivative of s by a with respect to s, so it will be 1 by a, and further when you simplify this, you will have minus a square divided by s square plus a square into 1 by a. So one of the a gets cancelled, you will have d by ds into f bar of s is equal to minus a divided by s square plus a square, something like this. Okay, now you look at this, L inverse of minus d by ds of f bar of s, if it is there, then you can write t into f of t. So what is missing to apply N inverse? We need a minus sign, is it? So just multiply it by minus sign, so therefore minus d by ds of f bar of s becomes a divided by s square plus a square. Now apply L inverse, therefore L inverse of minus d by ds of f bar of s is equal to L inverse of a divided by s square plus a square. Or this implies L inverse of this, it is nothing but t into f of t, which I have already seen. So the LHS turns t into f of t, but you know what is RHS? L inverse of a divided by s square plus a square. It is sine at. I want f of t from here. So f of t turns out to be sine at over t. I hope it is clear to all of you. If you still have any doubts, do ask me in our WhatsApp group. We'll continue with one more problem on this type, so that will be more clear to all of you. So here is one more problem for you. Find the L inverse of s into log of s plus 4 divided by s minus 4. Okay, to solve this, once again, let us consider it to be f bar of s. So take all of you pen and a paper and start working the problem with me. So take f bar of s to be equal to s into log of s plus 4 divided by s minus 4. Now this can be written as s into, this is log of u by v, so you will have log u minus log v. So it is log of s plus 4 minus log of s minus 4. Take it this way. So this is your simplified form of f bar of s. Okay. Now, since we want to eliminate this log from here, we need to differentiate it. So differentiating with respect to s, differentiate it. So you get f dash bar, I'll write f bar dash. Differentiating, you will get d by ds of, okay, it will be better. You are familiar with d by ds, so let us take it as d by ds only. So d by ds of f bar of s will be equal to the derivative of this with respect to s now. So first, s as it is, derivative of the bracket, it is 1 divided by s plus 4 minus s as it is, derivative of the bracket term, which is 1 divided by s minus 4. Okay, derivative. Okay, now plus. Now you keep the bracket as it is, differentiate this s. So derivative of s is 1. So you'll get simply the bracket as it is, log of s plus 4 minus log of s minus 4. Complete the bigger bracket. Okay, I hope it is clear to you. First I am keeping s as it is, differentiating the bracket, plus now differentiate s, keep the bracket as it is. Okay, using u into v rule of differentiation. Now if you simplify this further, it will be s divided by s plus 4 minus s divided by s minus 4 plus log of s plus 4 minus log of s minus 4. This is the way you can do it. So this is d by ds of f bar of s. Now just check here. Have we eliminated log completely? No. There is still log appearing here. So what we are going to do? We'll try to eliminate it by once again differentiating with respect to s on both the sides. Okay. So since log is not completely eliminated after simplification, so what we will do? Differentiating with respect to s again. So when we are differentiating this with respect to x again, see the left hand side is d by ds of f bar of s. Again if we are differentiating with respect to s, it becomes d square by ds square of f bar of s, second derivative of f bar of s, which is equal to, now you are going to differentiate this with respect to s again. Okay, so what do you get? Using u by v rule over here. So first, the denominator as it is, derivative of the numerator 1 minus numerator as it is, derivative of the denominator is also 1, so you will get s plus 4 whole square in the denominator. First the denominator as it is, derivative of the numerator minus numerator as it is, derivative of the denominator is again 1, so we will write it up till here. Minus, similarly on the next part, s minus 4 as it is, derivative of the numerator is 1 minus numerator as it is, derivative of the denominator with respect to s is again 1 divided by denominator square. You will get it something like this. Okay. Now plus derivative of this log with respect to s, it is 1 divided by s plus 4 minus derivative of this log 1 divided by s minus 4. Okay. Now further when you simplify this, plus 4 plus s minus s gets cancelled, you will have plus 4 divided by s plus 1 whole square minus, again minus s, actually you should take this in bracket. Okay. Oh, because there is a minus sign here. So minus, okay, let us simplify this. Plus s, again minus s gets cancelled. You have minus 4 into minus, it becomes plus divided by s minus 4 whole square you will get. Sorry, plus 4 over here. I had written 1, please correct it. It is 4 divided by s plus 4 whole square plus 4 divided by s minus 4 whole square plus 1 divided by s plus 4 minus 1 divided by s minus 4. This is what you get. Okay. Yes, now let us apply L inverse on the complete given thing. So therefore, L inverse of d square by ds square of f bar of s is equal to L inverse of 4 divided by s plus 4 whole square plus L inverse of 4 divided by s minus 4 whole square plus L inverse of 1 divided by s plus 4 plus, sorry, there is minus in between, minus L inverse of 1 divided by s minus 4. Now this is equal to, so see here, in place of s, there is s plus 4 whole square. Okay, I can take 4 constant outside, and to eliminate that this you can write, okay, I will not take even 4 outside. Okay, let us take 4 outside. E to the power minus 40 I can write first. Because in place of s plus simple s, you have got s plus 4 whole square. So there should be some power of exponential term appearing, that is e to the power minus 40 should be there. So the remaining part will write 1 divided by s square. Simply replace s plus 4 by s. So you will get 1 divided by s square. Okay, I hope this point is clear. Already we have solved a few problems on this. See here, whenever you have s plus 4 whole square or something, in place of s you have s plus something whole square or whole cube, that time what you are going to do, you are going to eliminate that exponential. Means what, there is an exponential part. I hope you all have remembered this property. I'll remind you. E to the power 80 f of t. If Laplace transform of e to the power 80 into f of t, if the Laplace transform of f of t is f bar of s, then the Laplace transform of e to the power 80 into f of t is f bar of s minus a. So in place of s, simply you will have s minus a everywhere. So in place of s here, you have got s plus 4. So definitely the value for a is minus 4. So it will be e to the power minus 40. Inverse Laplace transform of 1 divided by s square. Already 4 is been taken out. Similarly here, e to the power 40 you will get 4 outside. L inverse of 1 divided by s square plus, what is L inverse of this? It is e to the power minus 40 minus L inverse of this e to the power plus 40, and this part LHS, I will show you this part. L inverse of second derivative of f bar of s is t square into f of t. So let us write there the same thing. So you have t square into f of t is equal to this part. Okay, so this is equal to 4 times e to the power minus 40 into, what is the inverse Laplace transform of 1 by t square? It is t. Yes or no? 1 by s square. What is L inverse of 1 divided by s square? It is t. You have solved it so many times. Okay. In standard formula also I have given to you. Okay. Plus 4 into e to the power 40 into t plus e to the power minus 40 minus e to the power plus 40. Something like this. Okay. Now further you can take 40 common. E to the power minus 40 plus e to the power 40 plus e to the power minus 40 minus e to the power minus 40. Sorry, plus 40. You will have this way. Now I can just divide and multiply by 2 here. Okay. So it becomes, throughout if I divide and multiply by 2, you will have, if I multiply it by 2, so it will become 8t into e to the power minus 40 plus e to the power 40 divided by 2, plus here also I am dividing and multiplying by 2, so 2 into e to the power minus 40 minus e to the power 40 divided by 2 you will have. Okay, just see that. Now this is cos hyperbolic 40, this is sin hyperbolic 40. So the simplified form for this is, I shall do it here. See here all of you, we had stopped here f of 8, sorry, t square into f of t is equal to 8t into e to power 4t, because see here I am dividing, for this term I am dividing and multiplying by 2, even for this term I am dividing and multiplying by 2. So it will become what? If I multiply by 2, it will be 8t into e to power 4 minus 4t plus e to power plus 4t divided by 2. So if you cancel this, you will have still 4 there. Now even here for this term I am dividing and multiplying by 2. So if you cancel this, you will get back the same term. So there is no difference at all. So now this part is nothing but what? 8t into cos hyperbolic 4t or no? Plus 2 as it is. What is this? This is sine hyperbolic 4t. But this is in reverse way. So what we will do? We will take minus sign outside. 1 minute. It should be e to power plus 4t minus this over here. So it becomes here minus. So here you should get minus sign. Please check it, all of you. Okay, it should be like this. Or I'll do one more step for this. Actually it was like this here, is it not? If it is like this, we want to change it in this. So we will take minus sign outside from here. If you take minus sign outside, you will have, I'll do one step here. It will be clear to all of you. 1 minute. So it is t square into f of t is equal to 8t e to power 4t plus e to power minus 4t divided by 2 you all have, plus, since there is plus sign in between, see here from here I am taking minus sign common, okay. So if I take minus 2 e to power 4t minus e to power minus 4t divided by 2 you are left with. So this is nothing but what? I can change it as this to be cos hyperbolic 4t, this as 2 as it is, sine hyperbolic 4t, okay, sine hyperbolic, okay, hyperbolic 4t, okay. Now I want f of t from here, it is 8t cos hyperbolic 4t minus 2 sine hyperbolic 4t over t square. Over t square. This is the required solution for this problem. If you still have any doubt, you can just ask me in my WhatsApp group to clear your doubts. Okay. This is one of the important problems which I thought it should be cleared through your this, but there are still so many problems on this. You can still work on them. Search on your question papers, search previous year question papers. You will find so many problems on this logarithmic and inverse, and try to solve it by this method which I have shown you. Whenever it is log or cot inverse or tan inverse, always what you have to do is take it as f bar of s, then differentiate it. As long as you you should be able to eliminate that log and inverse function appearing there, and try to simplify it, and then apply this property which I have shown you here, this property. Either of the two properties you need to apply. If you are eliminated it by just one differentiating only once, then you can apply the first property. If you need to again differentiate it again in order to eliminate the logarithmic or inverse functions, that time you need to apply this second or the third also. You may be able to, you may not need to use it, okay. But most of the time they will use the first or the second only, not more than that. So better you remember all these steps, okay. All you have to do is take it as a bar of s, then differentiate it, and then apply the property. You will get the answer very simple, okay. Only while simplifying you need to be very careful, okay. So I'll just continue in my next class, next session. Till then, just thank you, okay, all of you. Continue in my next session.